All right, everybody. So in this video, I'll begin to illustrate to you the reduction of null productions on that. This will be another um method that we'll begin to run through. So reduction of null production is actually a rule where a non-terminal produces none or empty string, meaning the symbol can disappear. We remove these productions to simplify the grammar while keeping the same language. So in the null production process, it will allow us the non-terminal to disappear a derivation. We remove null production actually to like simplify the grammar if ever that we're trying to check certain string, and if that was achieved already, so we have to resolve it into string. We remove null production to simplify the grammar while still preserving the language that it generates. Now, removing this, making it easier to analyze and convert into normal forms like the Chomsky and Reback, and then identifying all this will be the steps that we have to consider. We have to identify all the nullable variables. A nullable variable is a non-terminal that can derive empty, like example A derive empty or n directly through a sequence of productions. Then next step for each production that contains a nullable variable, the right-hand side, create new versions of that production. In each version, the nullable variable may be either present or omitted. So in this particular work, you will already know how to do it step by step. Okay. Now let's move on to the next step. You have to also add all the new generated precision to the grammar. Make sure to update that one step by step, one at a time. Then this production preserves every possible derivation where nullable variables can disappear. So I'll begin to illustrate that in a while also. Finally, delete all the production, the empty production, since their effect is now represented by the new productions to the grammar, which is no longer needs rules of the form, like the sorry, let me just, okay, like this is here, um, for example, A direct to null, and we're able to simplify what will be the expected, what we call this one, production that we can replace aside from that. Okay. Now, next will be the resulting grammar is free of use this symbol, free from the null production. And it is smaller, clearer, and ready for conversion into the CF and the origin. So we're done with that one already. Now next, we have here a specific example. We need to work, we can walk with the terms of that, just copy that in my work on that step by step. Yeah. So before that, I'll begin to explain already here the advantages, the same thing from earlier, where actually it will simplify the grammar, removing unnecessary complexity by eliminating rows that need to be done. And it will also improve the parsing, reducing those ambiguity leading to confusion parsing. And then easier transformation to normal forms, besides the process of converting grammars into the CNF or the GNF. And afterwards, more efficient error detection. A simpler grammar makes it easier to detect errors in derivation. And afterwards, increase the number of productions. The process can sometimes result in more productions, particularly when nullable variables are involved. And also loss of space, some complexity over simplification will result in the loss of information needed for certain specific derivation. And also not always minimal, the resulting grammar may not be the most minimal grammar possible. And some complexities may remain. And compiler design simplifying grammars allow compilers to parse and generate code more efficiently. And those are the applications. And for automata theory also, Pushland automata, simplified grammars allow easier design of automata for complex query languages, and for NLP, it will simplify the parsing of NLP of natural language. I mean, removing ambiguities from the grammar and formal language theory also essential for simplifying the grammars of the language theory and proofs about the languages. And for removing the null production to simplify that one, removing null production streamlines the grammar by eliminating redundant rules that do not contribute to terminal derivation. This makes the grammar simpler and more efficient, and of course, for use in the theoretical and practical application, including compiler design, parsing algorithms, and automata theory. So let's actually go ahead and work on into the illustrations so that you will really understand on how to work on that. Okay, so right now here we have to identify first those nullable nodes. So what are those nodes that we do have here that can have now value which is a have x to have that. How can we work on this? Since in terms of that one, you have to check actually step by step. So I think I will just check this first, assess this first one, A and C. So let's right here check this particular details. So if A is nullable, so we can remove A. So what will gonna happen? It will become XB. All right. So since could be only one, removing one nullable, so could be XB. So otherwise could be if your S will be XB, you can also have because X is nullable. And if AXB na naman, you can also have a since X is also since X is also nullable. Okay? We can remove X, then here then we remove A. And we just use this one, and of course it will become B. Okay? Those are the things that we can achieve from this one. Okay? So afterwards, we'll just have to update the root production rule after you check for this one, we're able to finish the first set. So how to work on that? Update the production rule. Production rule is earlier is AXB. Then we have right now XB. We have B, and we have AB. And then afterwards, aside from that, we have to continue in terms of the A. We say since A is nullable, of course that we have to remove that one because for the nullable. So there's nothing to look in the particular structure. So X will continue to the X. So we just have to copy as is. Because I will just continue that process. Yeah. Now, afterwards, since we're able to finish the AXB, let's proceed with X since we removed A also. Then for X is equals to X X empty since A and X, so it will become either X. Okay, so you can produce X only. That is terminal X, okay? So what we're gonna do, you have to update again the production rule. So your production rule may be AXB, XB, then B, and then what about this one where X will be X and the really one X. This is the terminal X. And then afterwards, since here we'll just get assets. right? So this is how this will be the final production group after we remove null value. So hopefully we're able to follow the so first we're able to find here, second here then, and third we're not able to work on this because we cannot perform any operation since we just have to copy assets since there's no null there. And here for A, we don't have the right if because that is null there. Another example, since that is really so simple. So for example, we have here as A, C, and B, and A, A, and T, then B, um, B, A, C. Okay. Check if your one I mean the set that is actually considered as nullable right now. So the set that is nullable right now will be A and B. Yeah. Now assessing the we have to check this first. Yeah. Now as AC and B. So for SAC become either C since nullable A. Then for D, so that is empty. So there's nothing. It will be deleted as is. So therefore, after assessing that one, it will become your production rule will become S direct to AC, then D, and then really C. Afterwards, we'll have to check for A. A, we have the terminal A and non-terminal A. Yeah, so we do this automatically. So, alabang case, deliver. Yeah. So sorry. Your production rule pertains to that. So your A is then B then yeah, we're done with that. So we have assessed this right now. Let's move it. So what we're going to do is we're able to assess that here that we have new is we'll have to update your production rule right now. Become AC, then E, then C. Your A, for D, happy was S, C. We're going to do assess this D. Super D is B. So remove the E because that is no longer so what going to happen? We have to update the production rule as AC and B, then C, then your A become like this, and then terminal symbol, then B, then terminal symbol. We give it to you right now. It is E. And then for C, if since there's nothing you can do for C, so it will become both keep as is. Okay? So we're done with this one. This is actually the final answer for getting the removing the knife. So of course it contains many possibilities for the production rule. So hopefully that you were able to understand this one. And I'll begin to illustrate as well in the secret video the removing of um the other unit production. Okay. Thank you so much everybody. And make sure to put the comments, comment also for your additional points. Thank you so much and goodbye.